The worry of asteroid and comet impacts has plagued the Earth for centuries. The Earth Protection League, EPL, a philanthropic group, is concerned with Earth's health and safety. They have supported activities countering pollution, global warming, and armed conflict. Our mission? Protect Earth from the threat of space object strikes. The EPL's requirements are as follows: 100% protection against a planetary mass extinction event, 75% protection against impacts with the potential for regional or city destruction with 1 million fatalities. We've determined we'll need 100% protection for objects at least 300 meters in diameter, and 75% protection for objects as small as 100 meters in diameter. In order to stop these objects, we must begin with detecting them and determining their orbits. We've decided to place our satellites at the second Sun-Earth Lagrange point L2, which is approximately 1.5 million kilometers from Earth. We'll have 4 Peru's detection satellites at L2, each imaging a portion of our field of regard, which is from 45 degrees to 108.7 degrees on either side from the Sun. Additionally, the field of regard includes imaging 14.7 degrees from the ecliptic plane. Our imaging process will be as follows. The satellite will image across each row before moving on to the next row. The satellites will take images which will be used for orbit determination. 3 images are required to create an initial orbit and air ellipsoid for the object. These images will be sent down to Earth via our ground stations. We will have 2, one located in Goldstone, California, and the other in Canberra, Australia. On the ground, we'll use the images from our satellites to propagate the object's trajectory and determine if it may impact Earth. If the object is determined to be a threat, we will then launch a pair of Prospect spacecraft in the next launch window. The spacecraft will be used to minimize the error in the object's trajectory. Each spacecraft will do a close flyby of the object and use a near-infrared camera and spectrometers to collect data. The data will then be sent to Earth using one of our 2 ground stations for further analysis. We will then refine the object's trajectory. We expect most objects will be determined as non-threatening. This requires the air ellipsoid to be outside of Earth's radius of capture. However, if the air ellipsoid enters Earth's radius of capture, the object will be classified as a threat. Then, we will launch a fleet of kinetic impactors, known as Protect spacecraft, to the object in the next launch window, along with another pair of Prospect spacecraft. The Protect spacecraft will use their near-infrared cameras to locate the object and perform corrective burns upon approach to hit the object. Upon impact, the Protect spacecraft will deflect the asteroid by changing its orbit. Each Prospect spacecraft will fly by after the impact to verify the effectiveness. We'll then be able to see if the air ellipsoid has moved beyond Earth's radius of capture. If it has not, we'll send another set of Protect spacecraft, but if it has, the object will be successfully mitigated.
El fracaso no es opción.
失败不是一种选择.
Scheitern ist keine Option.
失敗はオプションではありません.
Saan arumbeng nga pagtalgedan ti pinakapaay?
실패는 선택이 아니다.
Failure is not an option.